Hello, good evening, students. I hope you all are fine. So, in the last class, we have seen plastic limit of soil, and also we have seen shrinkage limit of soil experiment, optimum moisture content, and all. So, in today's class, we will see one more experiment related to geotechnical engineering. I hope you all are fine. So, I'm sharing the screen. You tell me whether it is visible to you or not. You just drop a message in the comment box. So, in the last class, we have seen the experiment related to your plastic limit and optimum moisture content and dry density and all. I hope I am audible to you all. So I am sharing the screen. Hope it is visible to you. If not, you let me know. So in today's class, we will see the experiment related to what you can say permeability. Because in the last class, we have not seen the experiment related to permeability. So in today's class, we will see the what you can say experiment related to constant head permeability testing, falling head permeability testing. Give me 2 minutes. It is the internet issue. Shh. Ah, ada baik baik right. Determination of permeability of soil sample by constant head method. So to determine the permeability of soil by constant head method, the rate of flow under laminar flow condition through a unit cross-sectional area of porous medium under unit hydrogradient is defined as coefficient of permeability. So how we are defining permeability? The rate of flow under laminar flow. So as you know that there are two types of flow, laminar flow and turbulent flow. So if the rate of flow is under laminar flow conditions through a unit cross-sectional area of porous medium under unit hydraulic gradient is known as your coefficient of permeability. Unit hydraulic gradient normally is calculated with the formula I equal to HO by L. So if the rate of flow is under laminar flow conditions through a unit cross-sectional area of porous medium under unit hydraulic gradient, it is defined as coefficient of permeability. Water flowing through the soil exerts considerable CPS force, which has direct effect on the safety of hydraulic structure. The rate of settlement of compressible clay layer under load depends on its permeability. The quantity of water escaping through and beneath the earth dam depends upon the permeability of the embankment and its foundation respectively. The rate of change of discharge through wells and excavated foundation pits depends upon the coefficient of permeability of soil. The shear strength of soil also depends indirectly on permeability of soil as dissipation of pore porosity is controlled by its permeability. So what are the specifications used? IS 2720 17, 1986. Did the methods of test for soils, part 17. This test is used to determine the permeability of granular soils like sand silt gravels containing little or no silt. So, what are the equipments required? Perimeter mold of non-corrodable material having the capacity of 1000 ml. The mold shall be fitted with a detachable base plate and removable extension counter. Compacting equipment 50 diameter circular face, weight 2.76 kg and height of all 310 as specified in IS 2720 Part 7 1965. Drainage bed, a bed with a porous disc 12 thick which has the permeability 10 times the expected permeability of soil. Drainage cap, a porous disc of 12 thick having a fitting for connection to water inlet or outlet. Constant head tank is suitable water reservoir capable of supplying water to the perimeter under constant head. Next, graduated glass cylinder to receive the discharge. A stopwatch to note down the timing. A meter scale to measure the head difference in length of specimen. So, what is the thing? The knowledge of this property is much useful in solving problems involving yield of water-bearing strata, seepage through earth dam, stability of dams and embankments of canal bank affected by seepage, settlement, etc. Permeability of soil can be determined from Darcy's law. The equation to determine the permeability of soil using constant head permeability test is given by K equal to Q into L divided by A into H into T, where K is the coefficient of permeability and Q is the volume of water collected in time T, and H is the head causing flow. A is the cross-sectional area of sample, L is the length of sample. Now, a constant head parameter shown symmetrically in the figure. For a typical setup, the following dimensions are used. Internal diameter of the mold is 100 effective height of the mold is 127.3 detachable collar 100 diameter and 60 height, drainage base having a porous disc, weighing balance and other accessories. So, what are the precautions you need to take? All possible leakage of joints must be eliminated. Porous stones must be saturated before being put to use. De-air and distilled water should be used to prevent choking of flowing water. Soil samples must be carefully saturated before taking the observation. The use of high heads which result in turbulence should be avoided. So these are the precautions which you need to take. So now coming to the procedure part. A constant head test assembly is given as shown in the figure below. Select a representative sample of soil mass of about 2.5 kg, properly mix. So what you have to do, a constant test assembly is shown as in the as shown in the figure. Select a representative soil mass of about 2.5 kg, properly mix. Fill the soil into the mold and compact it to required density by making use of suitable compacting devices. Set the assembly as shown in the figure after saturating the porous stones. The water supply is properly adjusted to maintain the constant head. After that, what you have to do, you have to open the valve and saturate the sample by allowing the water to flow through for a sufficiently long time to remove all air bubbles. What you have to do, first you have to water supply is properly adjusted to maintain the constant head. Because it is a constant head permeability test experiment, you have to maintain the head as constant. And after that, you have to open the valve and saturate the sample by allowing water to flow through for a sufficiently long time to remove all air bubbles. When the whole setup is ready for the test, open the valve, allow the water to flow through the sample. Collect water in a graduated jar, starting simultaneously spot oil. What you have to do when the whole setup is ready for the test, you have to open the valve, allow the water to through the sample, collect water in a graduated jar, starting simultaneously a stopwatch. After that, what you have to do, note the time to collect a certain quantity of water Q. Repeat the test 3 times to determine the average of Q for the same time interval T. After that, what you have to do, the head, measure the head H, length of the sample L, and calculate the cross-sectional area A of the sample. Calculate K by making use of the equation. So the length of the soil sample L is equal to dash centimeter. Diameter of soil sample D is equal to dash centimeter. Area of sample A is equal to the centimeter square. Constant head is equal to centimeter. Now quantity of water Q is in ml, time t in seconds. So your K is equal to QL divided by 80 centimeter per second. So what is Darcy's law? For pre-viva questions, what is Darcy's law of flow velocity through water is limitation? So Darcy's law states that V is proportional to I. In order to remove this constant, K is introduced V equal to Ki. I is equal to H by L. What are the steady and unsteady flows of water? If the water is flowing steady, it's got steady flow. If it is flowing unsteady flow. What are the laboratory methods to determine coefficient of permeability of soil? Select their suitability. So this you need to study. What is the effect of entrapped air on the coefficient of permeability of air? Entrapped air causes changes in the values obtained of coefficient of permeability of soil. Constant head method is suitable for what type of soil? Clay soil. Soil with larger wastage has lesser or more permeability. Lesser. Coefficient of permeability is also called as coefficient of permeability is also called as permeability. Coefficient of permeability of soil is equal to centimeter per second. Next, verification or what you can say validation. The table below gives rough values of the coefficient of permeability, type of soil, value of permeability. If it is gravel, then the value of permeability is 10 raised to 3 to 1.0. If it is sand, it is value is 1.0 to 10 raised to minus 3. If it is silt, then its value is 10 raised to minus 3 to 10 raised to minus 6. If it is clay, it is value less than 10 raised to minus 3. So the conclusion is the type of soil tested is the permeability falls in the range of pre-bio, post-bio question. Will the probability of salt cause seepage of water through the earth layer? Yes. In the above case, what we can do to reduce seepage? We can use lesser diameter pipe. What does Darcy's state? This already we have to. Now, falling head permeability test for grain soil. Till now, what we have studied is constant head permeability test. Now we will see falling head permeability test. To determine the coefficient of permeability of a given sample by variable head permeability test. So the passage of water through porous material is called seepage. So how you will define seepage? The passage of water through porous material is called seepage. A material with continuous void is called a permeable membrane. A material with continuous voids is called permeable membrane. Hence, permeability is a property of a porous material. Hence, permeability, how we are defining permeability, it is defined as rate of flow of water under laminar condition through a unit cross-sectional area perpendicular to the direction of flow through a porous medium. You see it carefully how we are defining permeability. Permeability is nothing but it is defined as rate of flow of water under laminar condition through a unit cross-sectional area perpendicular to the direction of flow through a porous medium under unit hydraulic gradient and under saturated temperature condition. That also is very important. Now we will see specifications. What are the specifications? We need to understand. Specification IS 272017 1986. So what are the specifications we are using? In the specifications part, what we are trying to say, IS 27201986 methods of test for soils. Part 17, this test is used for fine grained soil with intermediate and low probability, such as silts and clay. This test method can be applied to an undisturbed sample. So equipments, what are the equipments required? All the accessories are same as that of constant head permeability test. All the accessories are same as the constant head and the falling head permeability test. Sorry for the inconvenience. Where did we stop? Falling head permeability test. Equipment required. All the accessories are the same as the constant head test and the following. So graduated glass standpipe and the clamp, supporting frame and the standpipe. All the accessories are same as the constant by the frame. Graduated glass standpipe and the clamp, supporting frame for the standpipe and the clamp. Theory: the falling and permeability test involves flow of water. What did it involves? It involves flow of water falling at permeability test involves flow of water through a relatively short soil sample connected to a standpipe, which provides the water head and also allows measuring the volume of water passing through the same. The diameter of the sandpipe depends on the permeability of the tested soil. The test is carried out in a falling head permeability cell. Before starting the flow measurements, the soil sample is saturated and the standpipes are filled with DA'd water to a given level. The test then starts by allowing water to flow through the sample until the water in the standpipe reaches a given lower limit. The time required for the water in the standpipe reaches a given lower limit. The time required of the water in the standpipe to drop the upper flow is recorded. Often the standpipe is refilled and the test is repeated for a couple of times. The record time should be same for each test, then the level variation 10%. Otherwise, the test is failed. So I'm sharing the screen. You just tell me whether it is visible to you or not. Now, so the below test can be calculated using the formula K is equal to 2.3 into small a into L divided by A into T2 minus T1 divided into log of H1 by H2 to the base 10, where L is the length of soil sample, column A is the sample cross section, small a is the cross section of the standpipe. T2 minus T1 is the recorded time for the water column to flow through the sample. H1 and H2 is the upper and lower limit water level in the standpipe measured using the same waterhead interference. So what are the precautions you have to take before carrying out this experiment? All possible leakage of joints must be eliminated. Porous stones must be saturated before being put to use. De-aid and distilled water should be used to prevent choking of flowing water. Soil sample must be carefully saturated before taking the observation. Use of high heat with resultant turbulence should be avoided. Procedure. So what is the procedure? You have to open the valve in the standpipe and the bottom outlet. Ensure that the soil sample is fully saturated without any entering of air bubble before starting the test. So what is the first step? You have to open the valve in the standpipe and the bottom outlet. Ensure that the soil sample is fully saturated without any entrapping of air bubbles before starting the testing. After that, what you have to do, fill the standpipe with water, keeping the valves V1 and V2 open, and allow the water to flow out throughout the pipe for some time and then close the valve. After that, what you have to do, you have to select in advance the heights H1 and H2 for the water to fall and determine the height H1 and H2 and mark this height on the standpipe. Open the valve and find the standpipe with water up to height H1 and start the stopper. Record the time interval for which the water to fall from height H1 to H1 H2 from H1 H2. These two time intervals will be equal if a steady flow condition has been established. Repeat the step E at least after changing the heights H1 and H2. Stop the test and disconnect all the parts. Take a small quantity of sample for water content determination. So you just go through the steps. So what are the observation? Length of sample L, it is in centimeter. Diameter of soil sample is D. Area of soil sample is A. Area of standpipe is small a. Area of standpipe is small a. Computation of coefficient of permeability. Serial number initial head H1 in centimeter, final head H2 centimeter, time T second. So your K comes out to be 2.3 into A into L divided by A into T into log to the base 10 H1 by H2. A fully saturated soil is said to be in which phase? It is said to be in three-phase. A valid range of degree of saturation of soil in percentage is 50 to 60%. If the voids of a soil mass are full of air only, then the soil is termed as dry soil. Which method is most suitable to determine permeability of clay soil? Constant permeability test. Is there any connection between permeability and temperature? No. In case of natural deposit, permeability is higher parallel to satisfy the flow. Yes. Result. Coefficient of permeability of soil K is equal to dash centimeter per second. Verification or validation. The coefficient of permeability of a soil describes how easily a liquid will move through a soil. It is also commonly referred to as hydraulic conductivity of a soil. So this factor can affect by the viscosity or thickness or fluidity of fluid and its density. The number can also be affected by the void size or region of non-soil violet content and the soil particle shape and surface roughness. It is an important factor when determine the rate at which the fluid will actually flow through a particular type of soil. Type typical permeability coefficients for different soils. Soil type typical permeability values. Suppose it is gravel and coarse sand less than 10 raised to minus 1. For fine sand, 10 raised to minus 1 to 10 raised to minus 3. Silty sand, 10 raised to minus 3 to 10 raised to minus 5. Silts, 10 raised to minus 5 to 10 raised to minus 7. Clay, less than 10 raised to minus 7. Conclusion. As per the value of coefficient of permeability, dash step yourself from the above table. Post Viva question. Why is variable head method required to find permeability? What are the important steps in the experiment? What is the time gap between to take the readings? So our next experiment is determination of liquid limit by static cone penetrometer test. So before we go forward, you just take a snap of this as it will be helpful for you even in competitive exams and all. It will be helpful for you. Soil type, typical permeability K in centimeter per second. If it is suppose gravel and coarse sand, it is greater than 10 raised to minus 1. If it is fine sand, it is 10 raised to minus 1 to 10 raised to minus 3. If it is silty sand, 10 raised to minus 3 to 10 raised to minus 5. Silts 10 raised to minus 5 to 10 raised to minus 7. Clay less than 10 raised to minus 7. So as per the value of coefficient of permeability, dash type of soil from the above table is calculated. It is posed by a question. Why is variable head method required to find permeability? I will just go through it once. You just listen it carefully. So our aim of the experiment was to determine the coefficient of permeability of a given soil sample by variable head permeability test. There are two types of tests: constant head permeability test and falling head permeability test. So constant head permeability test already we have studied in the last class. So now we are studying falling head permeability test. So falling head permeability test is very important test, and before going forward we need to understand what we mean by permeability. So what is permeability? Permeability is nothing but property of a soil particle up to how much extent it can absorb the water beneath it. That is, the passage of water through porous medium is called seepage, or it is also known as permeability. A material with continuous voids is called a permeable material. So which type of material we call it as permeable material? If continuously voids are present in it, then we call it a material as permeable. Hence, permeability is a property of porous material which permits passage of fluids through interconnecting conditions. So, due to the presence of voids, this permeable membrane allows the water to flow through its interconnect conditions. So, this phenomena is known as your permeability. Hence, permeability is defined as a rate of flow under laminar condition through a unit cross-sectional area. So how much area we are assuming? 1 meter per second square, 1 meter square unit area we are assuming. So how we are defining permeability? Permeability is defined as rate of flow of water under laminar condition through a unit cross-sectional area perpendicular to the direction of flow through a porous medium. Perpendicular to the direction of flow through a porous medium unless a hydraulic gradient under a hydraulic gradient and under a standard temperature condition. So temperature also has an effect on coefficient of permeability. So what are the specifications? We are using IS 1986, which is the methods of test for soil part 17. This test is used for fine grained soils with intermediate and low permeability such as silts and clays. So this test method can be applied to an undisturbed sample also. So what are the equipments required? So all the accessories are same as the constant head test and the following. Same apparatus which was used for constant apparatus, the same apparatus can be used here also. What what is the equation used? K is equal to 2.3 into small a into capital L divided by a into T2 minus T1 log to the base 10 H1 by H2, where L is the length of the sample, a capital is the sample cross section, small is the cross section of the standpipe. T2 minus T0 is the recorded time for the water column to flow through the sample. So what are the precautions you need to take? All possible leakages must be eliminated. Porous stones must be saturated before being put to use. De-aid and distilled water should be used to prevent choking of flowing water. Soil sample must be carefully saturated before taking the observation. So what are the observations? Length of soil sample, diameter of soil sample, area of soil sample, area of standpoint. So K coefficient of permeability you can calculate using the formula K is equal to 2.3 into small a into capital L divided by A into T into log to the base 10 H1 by H2. So which type of questions you can expect in the Viva are given below. If you have any doubts or queries, you can just place in the comment in the chat box. And if you have any queries, you can mail me at nadeem@university. And even if you can have contact me at my mobile number during night hours, 8 at 8553 1718.